Hello everyone, in today's session we'll be learning about data processing instructions. Okay, so what are these data processing instructions? In the ARM architecture, data processing instructions are a fundamental set of instructions used to perform arithmetic, logical, and comparison operations on data held in registers. Okay, these instructions do not access memory and they operate purely on registers. If you consider, let me start with the instruction format for data processing instruction, which is nothing but so this is a general instruction format for data processing instructions. Okay, opcode here, this represents the instruction mnemonics like add, subtract, etc. Okay, then we have optional conditional codes, okay, like EQ, NE, etc. This makes sure that this instruction is executed only if this particular conditional code is true, or only if this particular condition is true. Optional flag is used to update conditional flags in the CPSR. Okay, this sets, if yes is written here in the instruction, it sets the conditional flags. You can either include it in the instruction or you can skip it. RD is destination register, RN is first operand register, operand 2 is second operand, can be register or immediate value, possibly shifted. Okay, the different categories under data processing instructions. The very first thing that will come into picture is arithmetic instructions, and examples for that could be add, add with carry, subtract, subtract with carry, reverse subtract, etc. And each one of them, okay, we will execute these with examples in Keel, and I'll show you how exactly it works. Okay, next we have logical instructions. Examples for that could be, we have bitwise AND, bitwise OR, exclusive OR, and bit clear. Next we have comparison, and examples for that could be compare, compare negative, test and test equivalence. We have move and move not. Okay, we have multiply, which includes MUL, MLA, and sum O. Okay, this is multiply, this is multiply accumulate. Okay, then we have bit manipulation instructions, which involves all sort of shifting, such as LSL, which is logical shift left, LSR, logical shift right, ASR, arithmetic shift right, ROR, rotate right, RRX, rotate right extended. Okay, these are the different mnemonics which later gets converted to the opcodes. Opcodes are nothing but its binary versions which can be understood by the processor, whereas mnemonics are human readable versions of the same instructions. Okay.